Oh no, my crown got stolen! You, go get it back! Hello, we are the team Nutella Brötchen from the Lessing Gymnasium Neu-Ulm in Germany. And now we're gonna take you behind the scenes.
I'm Lisa and I do most of the programming and creative parts.
I'm Baha and I'm responsible for the entire spider.
I'm Johannes and I do the hardware.
I'm Pascal and I'm responsible for the LED matrix and the communication.
I'm Paula and I'm responsible for the pufferfish and most of the electronics.
At the beginning of the season, we come together as a team to develop the concept of the story and its characters, as well as the technical features and sensors we want to integrate. After the idea is finalized, we split the tasks according each team member's skills and update ourselves each week.
Our development process starts with the design of the robots using Autodesk Inventor. The components are then 3D printed and we receive custom cut aluminium parts from our sponsor Blech & Technik to build the frame.
At the same time, we design and assemble custom PCBs in Autodesk Eagle for each robot with its specific requirements. For the control system, we use the TNC 4.1 microcontroller, which is connected to motor drivers, an I2C bus and various sensors, as well as the ESP32 modules for communication. Especially the Spider's PCB was very complex and required a lot of further research about electronic circuits using SMD components due to the very limited space in the Spider's head.
Finally, the robots are programmed in C++ and MicroPython in the OpenMV IDE, and then we use GitHub for version control. To guarantee sustainability, we took items such as motors, wheels and the minions' frames and improved them. Our two minion agents, Bob and Stuart, guard the stolen crown in the story. They are driven by DC motors and use 3 omnidirectional wheels to drive in any direction. The minions have movable arms and eyes. At first, we used stepper motors to make the arms rotate, but they caused several problems as they moved down in front of the lidar sensors after some time and overheated quickly. We fixed this problem with servo motors that have 180 predefined degrees and work efficiently. The eyes are also driven by a servo and work with a timing belt mechanism allowing the minions to blink regularly. We integrated a B&O 055 compass sensor that manages the precise rotation of the robot. We regulate the orientation with a PD controller that ensures that the robot rotates clean and always returns to the demanded angle.
On their way, the minions also meet a pufferfish, which has 4 mechanism wheels to drive in any direction, 2 lidar sensors to orient like the minions, and also movable fins due to stepper motors.
The hexapod spider is equipped with 18 DS3240 servos and sensors such as a B&O 055 and BL53L1X. It has 4 NeoPixel eyes and a fictional power socket. It has also had multiple prototypes and 1 working version for the national championship.
Bus is the minions' transportation vehicle used to travel between the different performance stages.
The LED matrix is a display made out of 900 RGB LEDs split into 4 segments for easier transport. During the performance, it shows pictures and videos and serves as a dynamic background.
Our first feature is the PD-regulated orientation on stage that makes the robots localize and position themselves. The coordinates are updated by LiDAR light distance sensors on the side and back, up to 25 times per second. In the past, the robots overshooted the demanded position because of inertia, so we created the PD control. The proportional part makes the robot driving as fast as possible to the target point. The derivation part, the velocity of the robots gets subtracted from the prop and is calculated by the last 2 measurements. We chose this feature because it ensures the precise arriving to the point and allows dynamic moves, which is an outstanding part in our performance.
For the locomotion of the hexapod, the feet follow a Bezier curve. Multiple points are taken from the curve and giant angles are calculated by using a mathematical process called inverse kinematics. One major problem with the previous version from the German championships was unnatural movement, which was solved by custom molded silicone feet and better calibration. The reason we chose the locomotion of the spider as a feature is because of its complexity, mainly due to the mathematics used.
The next feature is the visual April tag track system. Bob and the spider can acknowledge and follow April tags with the OpenMV H7 camera. We calculate the distance of the April tag center to the image center to get the rotation factor, and the diagonal length of the tag to calculate the driving factor to the ideal position. We created different engaging objects with April tags that add to the performance. We chose this feature because it completes the scenes with robot-to-robot and robot-to-human interactions and make it more lively.
A frame made of square wooden stripes and 3D printed brackets provide the bus with stability. The bracket design allows for easy assembly and disassembly. The doors opened and closed using a 6-fold pulley system. The upper rollers will winch and its drive are powered by two belt-driven DC motors, all mounted in a custom aluminum part, laser cut and bent by our sponsor Brötchen technique. Pneumatics are used to extend and retract decorative elements. The system runs on a 1-liter air tank at a max pressure of 7 bar, controlled by two monostable 5 two-way solenoid valves. We've used pneumatics before, but this year we improved the cylinder mounts and bearings. We also switched from SLR to FDM printing for the brackets. FDM parts are larger but far more reliable, as SLR parts, while strong, lacked elastic deformability and would eventually break.
For communication, we are using the ESP-NOW protocol, which offers a more reliable connection compared to Bluetooth. Therefore, the other robots connect with the ESP32 server on the LED matrix. We need the communication in the beginning to start the timer on every robot so that they are synchronized and Box sends a signal to the bus when to open.